Howdy, and welcome to the Wild West of media performance, a Vox story. As Steve said, I'm Ian Carrico, a web performance artist over at Vox Media. You can find me on the internet at I am Carrico, pretty much every social media platform, including my website.
And I'm Jason Ormand, also working at Vox Media as a performance engineer. You can find me at Ocore on Twitter, and the same for GitHub, and Pyrometer on Wikipedia, which you'll just have to look it up to figure that one out.
So what is this? This is a story of us two performance engineers working on a legacy code base over at Vox Media for the past year and all of the lessons that we've learned. Practical tips on what we've altered in the Vox code bases, and this is for, if you're not familiar, Vox.com, Eater, Rack, Curved, SB Nation, Polygon, The Verge, and Recode are all on the same code base. As well as overarching lessons that we've taken from this process of if you're starting your own performance team, if you work in media, what you can be doing to help performance on your own sites in kind of a more broad spectrum look. So first, let's talk about the constraints that we had doing this on our own site. First off, as I already said, we have a legacy code base. The Chorus, the CMS that we built on, is a self-made Rails application that's been around since a while. And we can't go in and just magically upgrade it to something new because it is what it is and it's a monolith and we have to work with it. We also don't have the ability of going in and redesigning everything. We have 8 different verticals that have constant contact going through. So starting afresh, redesigning from the very scratch just isn't possible to do all of them at the exact same time. Oop. 1 second. I give up. I'm totally using the wrong screens. And then we also have 8 different verticals. So with all 8 of those sites, any change we make on one site is going to happen to all of them at the same time. So we need to make sure that any code change that we push will work on all 8 of those sites, not just a single one. Also, a fact of our life is that we have advertising. Our entire business model is based off of ads and ad networks. And we cannot get rid of that whether we want to or not. So no matter what we're going to be doing, we will have ads on our site, and we do just need to work to make those as good as we can. So our general plan, and this is a scene from the very famous 1963 film The Great Escape, Steve McQueen, coming up with a plan for his Great Escape. What do we do? First, we declare bankruptcy. We realize that we have gone over every single performance budget that we could possibly have set. And we have had for a very long time. So we need to admit that, and we admitted it publicly in a post when we started doing public blog posts on our performance and move forward. And then we execute a plan of exactly what you think. We would hit the large, easy wins first, and then we started moving down to more specific issues and drilling down to smaller and smaller issues that would take longer to fix. With that, hand it off to Jason.
Thank you. So since we started the performance team, the first order of business was to get our testing and tracking down. We wanted to establish a baseline for how all of our sites were performing in their current state, and then to be able to track any improvements or regressions over time. We had already been collecting RUM data for quite a while. We were just doing that through Google Analytics. It's really simple. It's on by default for new installations. So we had historical RUM data going back several years, which was really helpful to get an idea of, well, how our sites have been performing historically. And that data is pretty good for getting a sort of like big picture of what's been going on, but it's not very good for drilling in and actually debugging and fixing performance issues. So we decided that we definitely needed some type of synthetic testing solution to use alongside that RUM testing. We toured around and tried out a bunch of different software as a service synthetic testing services. And we also spent a little bit of time developing an in-house solution, which I built. It used web page tests as the back end. But that ended up just being a big time suck. And so we ditched that and went with SpeedCurve. And SpeedCurve is really great because it uses web page tests as a back end. And we were already super familiar with web page tests, so all the data and the stats that it was giving us didn't need to be reinterpreted. If we were using something that was Selenium-based, for instance, there might be some details about how they're interpreting results and how they're gathering their statistics, subtle differences between them. So we avoided that complexity by using something that already used a backend that we knew and loved. In addition to SpeedCurve, we also have a private web page test cluster, and that cluster is what we use to do all of our sandbox testing. Before we get anything actually deployed into production, we run it through our private setup and make sure everything looks like how it's supposed to look before it goes out. And we also test all of our in-house ads with that same cluster, and Ian's going to talk a little bit more about that later. And the flow for the performance team goes like this. We identify a problem area or an area that we think can be improved. We use Chrome DevTools mostly locally while we're developing a solution to verify that whatever it is that we're trying to address is trending in the right direction. Then we push that solve to a sandbox, and like I said, we test everything with web page test. If that looks good, then we go and make a pull request, and that gets reviewed by our entire team. And our team gets to look at the web page test results so that they can actually understand the depth of what's happening in that change. And then right after, if everything goes well and we get approved, then we go ahead and deploy that to production. And right after that, we kick off a big round of SpeedCurve tests on all of our sites. And we wait a little bit, and then we go back and we validate that the deploy went as expected. Sometimes you do tests in sandboxes, but of course sandboxes aren't exactly like production. So sometimes things don't go exactly as planned. So we just validate for sure at all the levels. Another pro tip, or a pro tip, is to use Git annotations in your synthetic testing solution. A bit difficult to tell from here, but for each one of those vertical lines, there is actually a short Git hash, and that makes it really easy for me to spot a violation. In this particular graph, you can see there's about a 2-second increase in start render time. This actually happened while I was on paternity leave, so as soon as I get back to New York City, I'm going to look up this Git hash, and I'll figure out who the author was, and then I'll contact that person and their team, and then work to figure out what caused that issue, and then how we can work together to get those 2 seconds back. And we also get notifications. We have a bunch of budgets set up in SpeedCurve for things like speed index and start render time, which if you watch the last presentation are perhaps slightly less relevant than I believed just an hour ago. But we track a lot of metrics. And so anytime we go over or under, we get notifications. And the performance team sees that all the time, whether a deploy goes out that we had done or it was another team that had made some change, we know the state of things. So this is the second pro tip. When you're doing synthetic testing and you're kicking it off right after deploy, a lot of times you have erratic server response times right after deploy. Could be that you have a big data migration, or you've got unicorns coming online and cooling down, and that erratic start render or server response time trickles up to all the other metrics inside of your performance stats, and then that will long cat notification inside of your Slack channel with 100 different notifications. So what we did was create a little background worker right after our deploy finishes up. We poll a Graphite server which contains the PERC 90 server response times, and we poll that server so that we don't start the test until they've returned to the levels that they were right before the deploy. And so that generally takes about 3 to 5 minutes. But every once in a while, it takes 15 or 20 minutes to get to normal times. And you can see the difference between the left side of the graph and the right. We have far less noise after deploying that. So we don't actually monitor every single page that we have. As a media company, we have a ton of them, to put it lightly. So I created this performance toolbar that I named Justice.js. And that gets injected into the page or loaded into the page for all of our logged in product team members. It just gives them pretty basic performance statistics, all using user timings, and I also included a little frame rate meter for fun. And it's been really great for increasing awareness across the team, if nothing else. So everyone now is thinking about performance every time they look at our pages. And the frame rate counter was actually really interesting because it's found a bunch of pages that had an issue with like parallaxing events. People had hooked into scroll events to do something fancy, and it ended up destroying the frame rate for painting on the page, and people weren't necessarily aware of it until they actually saw the graph, and it would dip down way into the 30 or 0 range. I built another tool. That tool is called Lightbike, and the idea was to prevent chubby assets from ever getting deployed to production. So once something is in production, it's actually pretty difficult to get it back out. So if you can prevent that from ever happening, then that's much better. And so what this thing does, it's relatively simple. For static assets like HTML, CSS, JavaScript, and fonts, it will look at your development version of your site as you're writing code, and it uses your browser, and it just rips a har out of there and does some quick analysis, and will spit out this fancy ASCII table of stats to see if you're over or under your budgets. So this is a really simple thing that any of our team members can use to help keep things nice and light. And we did use this while developing our new front end, which will eventually be powering all of the Vox Media sites. And I can tell you that it's definitely a lot leaner and a lot cleaner than the previous front ends. And I think that was definitely something that helped. So I would say the overarching lesson for us for testing was just to use RUM and synthetic. Neither one is sufficient. To run a performance team, you really need to have both data sets for analysis, and that would be my recommendation. Also going to talk a little bit about images. So you already know that images take up a huge percentage of web pages. You don't need to be told that. Again, everyone already knows that. And Vox Media brands use a lot of images. Our users love them. They're very impactful, and we can tell whenever we put a nice, big, beautiful image on a page that we get pretty good interactions on those pages. And it also happens to be an area of passion for me as far as encoding and optimization and delivery. So I got to work on optimizing our images, and we had already had this real-time image processing system called Thumbore. That's open source. Did I say that? Open source real-time image processing system. So that was doing all of our resizing and transcoding for our images. And we had a lazy loading technique in place where we were using JavaScript to load all the images on the page. And that was pretty cool because it saved the users a lot of bandwidth. If you didn't have an image area in the viewport, it would never load that image. So if you're on a mobile connection, that's great because you're never going to load an image. You're not going to waste that user's bandwidth. So that's a pretty cool stack already, but I knew we could take it a step further. So Thumbore could actually do WebP. Is everyone familiar with the WebP image format? Most people? Okay, so WebP supported in Chrome only, but our user base is pretty luxurious. We have like something 50 to 60% Chrome users across the majority of our sites. So it would be a really impactful change. And let's get to the business here. On the left, I've got the site loading, and it takes about 36 seconds, and that's without WebP. And then with WebP, a mere 12.8 seconds. So that was actually a massive win. That, of course, depends on, what format the editor uploaded the image in. But overall, we saw that there was a huge decrease in the page load time after deploying WebP. Okay, so lazy loading's really good at saving users bandwidth, but it's not good for getting an image on the page as quickly as possible. So for critical content, like lead images right at the top of the page of our articles, lazy loading really wasn't the best fit. What you need to be able to do is leverage the browser's preloader or look-ahead parser, and Souders has spoke about this endlessly. So you can use an image tag, but we use responsive images all over the site, so we use the picture element. just show you the before and after here. We're looking at about 23 seconds on the left, using the lazy loading technique to get the image on the screen, and the image comes in at about 16 seconds. By the way, the previous test and this test were both over high latency 3G connections. So I think 1.6 megabit, 300 millisecond round trip latency. So there's one issue that people don't talk about very much when it comes to images, which is image quality control. And what I mean by that is if you encode a JPEG with a quality of 80, that doesn't actually mean that you're necessarily going to get a JPEG that's 80% as good as the original. You might get an image that's 70% as good. You could get something that's 98% as good. And all that is really confusing to developers. The majority of developers aren't particularly nerdy about image compression. And it results in an inconsistent user experience. And we've had editorial staff come back and say, hey, you know, after compression, we had an issue with a couple of these images. And with a brand like Vox Media, we really care deeply about the user experience. And they find it kind of intolerable to have even mild variations in quality. So we don't have like super massive amount of time to go into all of this, but the takeaway is that the encoders and the optimizers and the processing systems need to tackle this issue of image quality control and then trivialize it for the end users of that software. I'm happy to talk more about that afterwards if anyone here wants to know more. And I am actually working on a solution for Thumbboard, the open source image processing system already. So Vox and anyone else could get that win. So I would just recommend to leverage the preloader for your critical images. WebP is an easy win, like just do it. And we definitely need better image quality control. And with that, I'm going to hand it back off to Ian. Thank you.
So one of my two areas that I have done a lot of work in for all of our sites is fonts. I'm sure everyone's first thought is that fonts are obscenely frustrating. Designers want them, developers generally don't, and they seem to always slow down the site in some way and annoy us. So we looked at this, we worked with our design team, found out, one, we did some auditing of removing some spare fonts that weren't being used as much. But then we redid the fonts that we are still using with Font Face Observer by Bramstein to watch all of our font loading events and check out when they're actually loaded so we can put them in. And effectively, all that Font Face Observer does is it watches their fonts. And again, this is the Watcher from Buffy the Vampire Slayer. He also just watches. And then we send in a function to Font Face Observer that when all of our fonts have loaded, we can do whatever we want to the page, whether that's add in a class, remove a class, add in some extra JavaScript, what have you. When we started doing this, we wanted to know how often this was working, how our page was actually loading. So we utilized Google Analytics to go in, and every time our fonts loaded successfully, we marked that. Every time they failed, we marked that. And we found out that our fonts were loading at about 93% of the time. And then we slowly dug into each and every one of those, which browsers it was failing in, why it was failing. We worked heavily with Bramstein to update a few minor bugs in older browsers. Oddly enough, the browser that we were having the most issue with was latest Chrome, which for some reason was just not having Font Face Observer for about like 3% of our fails. And we ended up implementing native font events on top of Font Face Observer. I gave a similar talk on this a while back, and Bram actually sent me an email to let me know that native font events are now built into Font Face Observer. So we now go completely Font Face Observer, and that uses native font events first. And then if those don't actually work, then it uses its own magic to see when fonts have actually loaded. Once each and every one of our fonts loads, we then add a class, which then shows all of our full fonts as we would expect them to. Most importantly, though, before those fonts load, we sat down with our design team and created a set of fallback fonts. So these are fonts that are naturally on each OS, or a set of fonts that would be on each OS. and we altered the font size, the font weight, the family, everything, so that the change between the fallback font and the font that we actually wanted was as least jarring as possible. So that when fonts actually did load in, they would come in a not as noticeable way as could happen. So here we have our, well, I actually start forgetting. This is our actual fonts, and these are our fallback fonts. So while you can see a difference, we've done a lot of work with our design team to make sure that the difference is relatively minor, and it should only happen on the first page load. We're having a few minor issues with some sites that we've increased the start render time in such a way that now we're having it on second load, but we're working through that. And the big takeaway from all of this work we did on fonts is that culture is absolutely critical if you want to get anything done. We were very lucky that when we started the performance team at Vox Media, we already had some buy-in or recognition that performance was an important idea. But just because you have buy-in by the upper echelon of executives saying that we can spend money on this doesn't necessarily mean that the entire team is ready to do this. But something like our fonts, we needed to involve our design team, we needed to involve our UX team, we needed to involve our testing team, we needed to involve our front-end developers, we needed to involve some of our back-end developers to make sure that our fonts were loading in an appropriate way and we could move some bundles around in an efficient way. And without buy-in from each and every one of those teams that this was important and this was something that we could spend time on for other teams, we would not be able to do any of the work that we have done. It is absolutely 100% critical that we have buy-in from everyone across the company. And as we make small improvements like this, and fonts was one of the big first things that I tackled, that buy-in has increased more and more. So now we have things like on our GitHub PRs, we have a reminder of make sure if you're adding more third-party libraries that you just check in with the performance team and make sure this isn't blocking or this isn't going to hurt page performance in a huge way. And all of that, our entire team is 100% behind. The other thing I work on now, I have been moved full-time to the advertising team, which I know is everyone's favorite subject. Yay, ads on media sites. No one's happy. And as we all know, ads, basically, this is Mr. Slow being stopped. So they're blocking, they're slow, no one likes them. But we take ads very seriously at Vox, and we believe very firmly that ads are not the problem that we see across the internet. Bad ads are the problem. So we work very hard on making our ads better, as well as making sure we have high standards for the ads that we add on to each page. So the first thing we do is for the ads that we build in-house to be displayed on our site, we have an entire system that we have built, that we have a bunch of templates and stuff that then content managers can go in and create different ads from various templates and move things around, things like that. But every time an ad like this is created, we run a full set of performance tests on it. And we, as the performance team, have set a variety of metrics that we pull from, and we decide whether it's a high-performing ad, an okay-performing ad, or a poorly-performing ad. So green, yellow, red. And we put this little rocket on the side. We refer to it as the speed rocket, where then every single content manager who has no idea what performance is, other than it's a thing that they should eventually probably think about at some point, can know immediately, is this something that's good? Is this something that might need a second look, or is this something that I need to contact the developer and see if we need to update this or fix this template in any way, shape, or form? So this is a quick and easy way for 100% non-technical people to get the information they need to raise a flag on their own work. And we're also actually, Jason just came with the idea this past week, we're going to start investigating putting this on all of our content pages as well, so that there is no immediate, you need to know these numbers or what the output of justice is doing, but just a simple green, yellow, red system of whether or not this is something that's good, okay, or bad. What we also have had is when we first put ads on our site, which was, again, many, many moons ago, the ad systems that were in place were all synchronous. They all were blocking. And we've had a set of ad code that has kind of followed us from the very beginning that has been not as efficiently written as it could be. So I was able to step back and rewrite our entire ad calling system from the absolute scratch. So we We rewrote it to put as much processing on the back end as we could. We put all of the 100% important scripts that were needed to get Google on the page and to define our ads inline in the head, as well as all of our ad slots definitions inline in the head. And then everything else, libraries, anything else was pushed down to the footer. And this required a lot of untangling of code, a lot of, there was a couple of assumptions in our ad code that jQuery would be present, so we had to remove all that. And we really did start from the very scratch to do all this, to rewrite our ads to be more efficient and to be as performant as possible. All of this resulted in what we have the before on the left, after on the right, where we've increased about a 40% improvement in our start render time, which, again, I just found out in our last presentation doesn't mean anything, so that's great. And ironically, my favorite part about this GIF is you can see on the right, we actually have an issue with our fonts that wasn't noticeable until after I improved our start render time. So now that I've done some improvements on our ads, I now need to go back to fonts and make sure that some of our assumptions are still accurate, which is one of my favorite issues to happen, that we've made part of our site more performant, that other performance fixes we've done in the past are not fast enough. But the big thing that we have taken from all of the work that we've done on ads, all of the time and issues that we pushed forward on this, is that for the performance team to actually be successful, and for any performance team to be successful, they need to be given the room to tackle some of the big projects. When we're working on a code base the size and breadth that Chorus has, we desperately need to be able to rethink a lot of assumptions, a lot of code that has been around for a very long time. And at first we were able to justify a lot of small projects here and there, but being able to really step back and look at the system as a whole has yielded far more results. It's part of what the image work that we've done has come from. It's what all of our ad improvements have come from. And all of this code is hopefully going to be pushed to all of our verticals so that we can have a much, much better experience for both of these things, as to be as far and wide as we can. So yeah, thank you for coming to our talk. That is it. And if you have any questions, yeah.
Did you see, or can you talk about any business impact you got by improving the performance of the ads?
Yeah, so we've actually been looking very heavily at all of our ad impressions as of late, because we've wanted to make sure that we are not doing anything foolish. And so the ad calling is currently only on the Curb network, or actually Curbed and Recode right now. Mm-hmm. And we're slowly migrating each and every site over to that. But Curbed has by far the highest ad impressions of any of our sites. Like most of our, I don't want to give exact numbers, but it's literally like 40% higher than other sites we're seeing right now.
And the bounce rates, whenever we took curb.com and pushed it from our old platform to the new one that I helped build, which had vastly lower load times, the bounce rate just was like a rock falling out of the sky, along with the load times. So the correlation, if you just naively looked at the load times in comparison to the bounce rates, they just followed with each other right along the lines, and there was a 25% drop in load time, there's a 25% drop in bounce rate. So 25% drop in bounce rate on pages, which is pretty massive. So yeah, that's definitely makes real business sense to make these investments.
Yeah, so especially, again, coming from a media perspective, we care about ads, we care about bounce rates, we care about people getting to our sites and staying and clicking around. And on all of the improvements that we've made, whole scale has been much, much improved compared to previous.
Yeah, a lot of stats are up across the board. Mm-hmm. Money stats, up. Perf stats, a lot faster.
Yes?
This problem is more for Jason. I just want to talk about, or ask about the interest. And I'll start with asking what the sort of like global user base is. And the second part of that is with your assertion that WebP was the answer in certain cases for the users. yesterday we just had some talk where Tobias was talking about really squeezing everything you could out of JPEG.
Mm-hmm.
Are you at all concerned with the sort of processing overhead of WebP? And that's why I go back to the mobile question. Is that going to be any hindrance?
Right. So one disadvantage of using WebP for us was I knew that it was going to have less of an impact on our mobile users because we do in fact have lower Chrome mobile usage, and those are the areas that we care about. If we had a choice to optimize something for desktop users or for mobile users, we would definitely target mobile users if we could. So it's not perfect, but it was huge, easy, and impactful. And as far as Tobias goes, and I talk to Tobias pretty regularly about image stuff, I definitely believe it's worth the effort of squeezing every drop you can out of a JPEG, but there's pretty significant investment of effort that you're going to put into that process as well. I would say that WebP is relatively easy to deploy. The tooling for it, I would say, just works. You can throw a pretty dumb setting at WebP and it will generate pretty good images for you, and they will definitely be smaller statistically than any other codec that browsers natively support. So I would say probably do both, and I do plan on, I've got a number of different image compression and optimization projects moving right now, and one of them is to work with the guys that are working on Mott's JPEG. They're building something called DSSIM, which is a tool that measures the psychovisual difference, the thing I was talking about earlier, the issue with quality control. They're building that into Mott's JPEG. And Mott's JPEG can be a little bit slow as a compressor, but it does get the JPEGs down a little bit more. But it's also going to be image quality aware. So I'm hoping that I can take some of these more advanced JPEG tools and help out, all those users as well. Yeah. Does that answer your question? Okay. Cool.
Yes, sir.
The comparisons you've made on slides are comparing a Vox site with a change to a Vox site without a change.
Yeah.
Do you ever compare those against a Vox site with content blockers?
I try very hard to every once in a while open up. I have one Chrome profile that has ad blockers and stuff on there. We don't do performance tests against ads versus no ads, but we do test no ads performance purposely to see what the effect of ads are having. And originally we started doing it so we could see our site as is without any third-party extras slowing it down. So we could see what specifically we can control and what we need to be looking at third parties to optimize them.
In the beginning, most of our work was scoped to things that were not ads. So to be able to actually see a 500 millisecond improvement in some small thing that we tweaked, we really needed to be able to not load ads. So we just, internally and locally could turn ads off and make them not part of the picture. As we've started to change the load order of things and keep them more separate, it's become less and less of an issue. And we've seen less deviation with some of the simpler stats like start render time and first paint. Yep.
Any other questions? Okay. You can find all of our slides. Here's a short link, but it's on my GitHub if you want to take it out, and we'll also tweet it out in a little bit. Also, we'd love to get any feedback. Feel free to tweet, or you can rate it in the app and on the site. And yeah, this is a production of Vox Product. Thank you all very much for coming, and we'll be around if you want to any more questions.
Hope you liked it. Thanks.